Oh,
Okay,
mm,
doctor.
so you can see the YouTube all there. Am I right? Am I right?
I can see a screen and the names.
You can see your name also stated there. Am I right?
Yes, doctor.
Yes. Thank you very much. Okay. Let's we go to the. Mhm. Okay. So now we are going to have a chat. Okay. All right. So, mm, hello, you all. Okay. All we are now at the air. So we are now together with Aziza, Amelia, Fatona, who are mm, already successful during the quizzes last time. Congratulations. So we invite you to join our class. Okay. Hello, Fatana. Hello, Amelia. Okay. Hello,
Hello,
Aziza. All right. So we're going to have the attendance after this. Okay. I hope all of you join us at the YouTube. Okay. Let's we go to the YouTube now. All right. So I want to see what happened to the YouTube. View the YouTube. All right. So it's all right. So everything fine. So now let's we okay. How are you, Fatana? Where are you now? In Kuala Lumpur, Johor Bahru.
I'm in Kuala Lumpur right now. I'm staying at my
All
home.
right. All right. Amelia, where are you, Amelia?
I'm from Johor, doctor.
Johor. Which part of Johor?
Batu
Near to my
Pahat.
house. Batu Pahat. Okay,
Oh,
Aziza.
okay.
Aziza, how are you, Aziza? We inviting Aziza. Where are you? In Batu Pahat also in Johor? Kelantan. All right. So okay, thank you very much for joining us. Okay, we inviting you because of that you are winning for the last quizzes. Okay, we are using Quizlet. And then now, okay, I want to share with you some information about, let I share with you the, what I have in the e-learning, all right? So I share with you now the e-learning. All right. So we put focus on the e-learning. Okay. Goodbye, all. Wait for a while. You are staying with me. All right. So now, when you go to the e-learning, okay, I think it's small or biggest. I'm not sure. Okay. I try to make it more biggest, 150. Okay. We just finished a class on the iterative method. All right. So I send you a class, a link. Okay, to deal with the Koleski, okay, YouTube link to the Koleski method. Okay, we finished already Koleski method. And now I also send the notes on Jacobi and Gauss-Seidel method, all right? And then we do some exercises to make sure that you can understand how to use your calculator, all right? So now, when you go to the YouTube, okay, when you go to the YouTube, you can get the lecture for last week, all right? So now I'm also request okay you um, to go to this one, all right? So if I can share with you, okay, this is another way how to make sure that I can check your understanding, yeah. All right, check your understanding. Share screen, all right? I go to my map, all right? Okay, if you go to this mind map, all right, I make it more bigger, okay, to make sure that you can see here. All right, I move on and put here in front. All right, so you can see here there is a chapter one. What we learn is a without condition and with condition. All right, I write very clear here. We learn already three methods: Newton, second, and fixed point method. And then for with the condition, we have a bisection and fault position method. So I need five group. Okay, I need five group. Okay, can you remember? Okay, who are still not answering for question? The last question. Okay, in factorization. So can I have a group here? All right. So give me your email, the leader, the email for the leader, because I want to send this, and then you can distribute to insert what is the example of the fixed point method, Newton method, and second method, and what you can elaborate based on this method. All right, you just very easy. Okay, you just plug in here. All right, I put plus. Okay, maybe you want to put more, so you click here. All right, and then you can get a plus, and then you can do it. All right, very simple. So this is for chapter 1. I will go for the chapter 2. All right, so I need the email for every group for me to send, to share with my map, okay, to your group. All right, so now I share with you. Okay, we continue. Amelia, Fatana, all right, Aziza. Okay, we finished already Koleski method. Am I right?
Yes, Doctor.
Koleski method. So, okay, good morning to Erin, Chi Yin Win. Okay, good morning. Okay,
Yes.
good morning also Purani. Good morning. All right, so now let's restart for our session. Okay, on solving the Thomas method. Okay, solving the Thomas method. All right, so let's I share with you all. Okay, here. And then I'm also want to share with you the PDF file. Okay, very easy for me to explain PDF file. Okay. All right, I go to Thomas method here. Okay. Okay. And then let's I make it more small. Very easy for us to look. Okay. So now I share with you the video. Okay. I share with you, stop sharing the video. All right. Thomas. Okay. I share with you the video about the Thomas method. Let's we go to Thomas method. Okay, backward. This one is a Koleski. Okay. This one is a Thomas method. Alright. So you stop here. Okay, so what do you learn about Koleski? Before we go to Thomas, what you learn about Koleski? Can I have a feedback from people here? All right, from the people, we have many people here. All right, so okay, we have Emilia, we have Aziza, okay, Fatana. Can you help me? What we learned before, all right, on the Koleski method? What you know about Koleski method when we are using Koleski method? Good morning, Jean. Okay, can I have some feedback from Emilia, Fatana, and Aziza? What you learned about Koleski method before we go to Thomas method? Koleski is a numerical method, iterative method. All right, iterative and not direct method. Sorry, it's not the iterative. There is a direct method. Okay, to solve a linear system of equation where the condition of matrix A it should be symmetry and positive defined. All right. So how to detect the positive matrix from matrix A is a equal to A transpose. Positively defined is a X transpose A, X should be greater than 0. All right, the value that you get from X transpose A, X should be greater than 0. All right, we learned about Koleski. All right, so now we go to the Thomas. Okay, Thomas method. Okay, Thomas, same as Koleski, we solve a linear system. Okay, we can use a direct method. We need to solving using the L and U, lower and upper matrices. All right. Koleski, L and L transpose, okay, is equal to A, meaning that upper is a L transpose. For Thomas, okay, matrix is diagonal matrices. Okay, diagonal matrices. Now let's restart. All right. Okay, we go to the Thomas method. Okay, Thomas method. Okay, Thomas method is used to solve a linear system where the matrix A diagonal. What do you mean by matrix A diagonal? Meaning that all the diagonal value is not equal to 0, but the rest is a 0. So Aij is a member of A is called diagonal if Aij is equal to 0, meaning that all the value upper and lower is a 0 for I minus j less than greater than 1. So that's 0. So meaning that location for Aij is I on the row I and j is a column j. Alright. So for example, here is considered as a diagonal matrices. Why? Because the upper and lower is 0. The rest, okay, at the diagonal and diagonal, lower diagonal, upper diagonal is not 0. Alright. So that's we call diagonal. Alright. Please remember. Okay, diagonal, all the upper and lower matrices 0 unless there is a 3 line here. Okay. Upper and lower diagonal is not 0. Alright. So now, the question here, how to factor matrix A? Okay, because we know how to factor Cholesky, L transpose. Okay, U is a L transpose. We know how to decompose matrix, full matrices using bisection and using Dolittle and Kraut. Alright. So now how to decompose matrix A to lower and upper. Alright, to lower and upper. But the lower should be dual lower. U is a dual upper, alright, because the 0 at the corners, alright. So now, as usual, we need to decompose lower and upper, alright. However, diagonal matrices, okay, involve 2 lines for the lower, 2 lines for the upper. We call as a dual lower matrices or dual upper matrix, alright. So now, as usual, okay, let's say I have how many matrices here? It's a 3 by 3, all right? It's a 3 by 3, how many? This one is so many. All right, this one is a 4 by 4, 4 by 4 matrices, all right? Why I can increase the size of matrix? Because you are lack of the calculation. So the lower is a B, C, D, E, F, G, all right? All the diagonal A, C, E, G, and then there is a 1 line at the lower, okay, of the diagonal B, D, F. For the upper, all right, you can use Kraut. This one is a Kraut style. Okay, Kraut style, the diagonal is always 1, and then the upper value Hij, okay, is also have a value, but dual upper. All right. So I repeat again, dual upper. All right. So in your case here, okay. All right. So I want to share with you that I have so many here. Aziza, Amelia, okay, Fatana. All right. So Amelia, Aziza, we need to have, all right, the decompose for matrix LU for matrix A is a Thomas, is based on the Kraut. Okay, Kraut and push because the diagonal for matrix upper is 1. All right. The lower matrices and upper matrices is not full. Okay, full matrix. This is a dual lower or dual upper. So what should you get from here? You get from here, okay. All right. You get from here. Okay, some parameter you need to find. Only A, B, C, D, E, F, G, H, I, J. All right, H, I, J. So meaning how many? 10. Okay, 10 parameters you need to find when you match between L and U multiplication and matrix A. All right, so now, okay, you can also use Dolittle. Okay, because the way you do also same. The parameter that you need to find also you have 10, A, B, C, D, E, F, G, H, I, J. Okay, all right. So also have, but the value for diagonal, okay, matrix L is always 1. This one is a Dolittle style. So it depends on you. You can solve Thomas using Kraut style or Dolittle, but always use Kraut because the example is Kraut. All right. Okay. Okay, so now we apply, okay, Ax equal to F. We decompose, we factor A to L and U. All right, U is a dual lower, L is a dual lower, U is a dual upper. So as usual, we need to do another step. you need to assume that ux is equal to w. All right. So and lw is equal to f. So in this case, you need to solve lw equal to f using what? Using forward substitute, and ux equal to w using backward substitute to get what is x. Okay, the answer is you want to find x. Similar. So now, let's go to the example of this matrix. Okay, we want to solve this matrix using Thomas. Why? Because you can see the matrix is a diagonal matrices. Okay, we can arrange this matrix, and then the size of matrix is a 4 by 4. I can extend the size of matrix because the matrix is not full. The matrix is a diagonal matrix. All right. So we can apply Thomas, factorization using 4 decimal places. So you please press your calculator, mode fix 4. All right. So now I transform from the linear system to the matrix form. All right. So in this case, I want to share with you. All right. Maybe I can ask somebody here. Okay. Maybe Fatana, Aziza, Amelia. All right. Or people out there, how you want to transform the linear system to matrix form? Can I get the answer from Aziza, Emilia, or Fatana? How you transform the linear system that you get here to the matrix AU equal to F? Can you do that, Aziza? Can you do that, Aziza? Aziza, you are in the group. You hear me? Am I right? Can you unmute? Can you mute your voice? Sorry. Can you mute your voice, Aziza? Or Amelia, can you mute your voice?
Yes,
Siapa tu? Amelia. Amelia, can you transform from linear system to matrix AU equal to F for this matrix? Can you do it?
Yes, doctor.
Yes, can. All right. So yes, very good. All right. So wait for a while. Okay, I want to express myself for this. Okay, next step. So of course, you already decompose matrix A to LU. All right. I told you. Okay, I want to focus on crowd factorization where upper for matrix U is always 1. Diagonal is always 1. So I already composed. Okay, X equal to F, where A is a 1300. Okay, the second row is 1210. The third row 04, negative 15, and then the last row is 0023. So you can see here the matrix is a diagonal because upper and lower is always 0. All right. So the composed matrix. Okay. So you must detect this is not Dorital, this is not Crowd, this is not Koleski, but this is a Thomas because the matrix is a 0. So you develop the matrix lower. Okay, matrix lower. All right. So since to reduce the calculation, since we know already how Dorital and Crowd used to reduce the calculation, Thomas also same. 142 you just get from the element for A21, okay, A32 and A33. All right, so you just plug, okay, you just take it all the diagonal, lower diagonal for matrix. Okay, lower is 142. The rest is the parameter A, B, C, D. All right, and then because we are using crowd, so the diagonal for upper is always 1, kan? Tengok tu, 1, 1, 1, 1. And then the parameter you need to find is EFG. So how many parameter now? You reduce the parameter from 10 because you know what is a ABC or CDF. Okay, you know already the value of BDF, all right? So A, okay, this one is a value A to 1, B 32, C 43, all right, 43. So this one is already we get from the question from the matrix A, all right. So I delete here. So I put A11, A22, and A3. This one is A43, A332. Okay, so I already mentioned the value for A21, be careful, A33 and 43. you need to replace here 142. All right, if you are using Dolittle for crowd, 142, okay, you can get from the matrix A. Okay, why? Because we want to reduce the calculation. So the parameter you want to find now is A, B, C, D, E, F, G. It's only how many? A, B, C, D, E, F, G. Okay, so you have 7. Okay, you have 7 parameters. All right. So as usual, okay, please do the matrix multiplication between L and U. All right. Do a matrix multiplication L and U. Okay, be careful. Okay, when you do, because the size of matrix is very huge. Okay, it's a very huge. All right. So be careful. Can you do? Very easy. All right. So now I want to share with you. With Emilia, Aziza, and Fatana. All right. I call upon, do you know how to do a matrix multiplication for 4 by 4 matrices? Emilia, you know how to do that? Fatana?
Yes,
Yes.
doctor.
Yes, kan? Okay, but it's complicated. Why? Because the matrix is a 4 by 4. Why? Because the matrix is a 4 by 4. All right. So now I share with you. Okay, we continue. 4 by 4 matrices. Okay. Okay, we do a matrix multiplication. This is a value. Okay. All right. So the matrix is a, B, C, D, E, F, G. All right. The diagonal at the upper is always 1 because this is a crowd style. We want to reduce the calculation. All right. Okay. The next step, same as Dolittle, same as crowd, Koleski. We need to do matrix multiplication for 4 by 4. Be careful. See, I'm doing 4 by 4 matrices. A, E, 0, 0, A, E plus B, B, F, 0, 0, 4, 4, F plus C, and then C, G, and then 2, 2G plus D. All right, so this is the matrix multiplication that I got when I do the matrix L times matrix U. All right, so now let's match. Don't forget, we already have the right hand side and then the left hand side. The matrix A is a 1, 3, 0, 0, 1, 2, 1, 0, 0, 4, negative 1, negative 5, 0, 0, 2, 3, where you get from the question that we have here. All right. So now, when we match between A and U, you can get this value. You can see here. Okay. A equal to 1, AE equal to 3, you will get E. Be careful, yeah, because this is a dependent, variable that you want to find. Okay, for example, B, E plus B equal to 2, so B is a 2 minus E. All right, BF, is equal to 1, so F is that 1 over B. For F plus C, negative 1, so C is equal to 3. So it depends on the value from the previous step. CG equal to negative 5, G is a negative 5 over 3, and 2G plus D equal to 3, D is equal to 3 minus 2G. So be careful. This step you need to be careful because when you do match L times U and match with matrix A, you need to put a sequence. Okay, see the sequence? Find AE first and then B plus E and then B plus F, the limited parameter you want to find, and then for F plus C, and then CG, and then 2G plus D. All right, so there are very lack of the calculation because at the diagonal and lower matrices for LU is 0. All right, so this is a weakness, these are advantages for Thomas available to solve a diagonal matrix. Okay, we plug in matrix A. All right, see, lower is 0, upper is 0, but there is a value at the dual diagonal. All right, dual lower diagonal. For the crowd style for upper, you can see here all the lower is 0. Diagonal is always 1 because we want to use crowd style, and then the dui upper also we have a value. All right, value apa tadi? F. What's the value? The value is EFG. EFG. So we have all the value EFG. All right. So now, as usual, Okay, we learned already using Dolittle, using crowd, using Kolesky. We need to assume, okay, W as a UX. All right, so in this case, you need to find what is W. All right, so we assume LW equal to F. I always use this terminology. Don't forget. All right, and then UX is equal to W. Later, I want to find X. But at this moment, I want to find L times W equal to F. F is given in the question. F is given in the linear system of equation. So now I plug all the value of L. All right. So as usual, I'm using a forward substitute, but the calculation is very minimum because the rest is zero. So you can get straightforward. W1 is equal to -1. W2 minus W, okay, W1 minus W2 is equal to 1. All right, so this one, you will get W2 equal to -2. Okay, the way you do forward substitute, you can use your calculator. All right. Or you can straightforward from your calculator because it's very simple. Only two terms you need to do the summation and multiplication. 4x2 plus 3x3 is equal to -20. So you can get W3. Okay, bukan X, W3. So the rest is a 2x3, okay, plus 6.6664 x4 is equal to 11. All right. So this is the way how we do a simple calculation, very lack of the computational cost when we are solving using Thomas, because the lower and upper is always zero. So we focus on the dual lower matrix. All right. So what happens if you want to use upper? Upper also all zero at the corners, but you have a dual upper matrices. The rest is zero. So you can see here how to get X. X1 plus 3x2 is equal to -1. All right. 1x2 minus 1x2 minus 1x3 is equal to -2. All right. So you use a backward substitute. So you can get x4 is equal to 3. Okay. And then you can get, because backward kan. So x3 and then x2 and x1. Very minimum calculation because your matrix is a diagonal. Only 3 value at the diagonal. Okay, exists. The rest is zero. For upper matrices, only dual upper matrices exist. The rest is zero. So very simple. So you will get the matrix A, okay, as a x1 1.9997, x2 -0.999, x3 1.001, and x4 is equal to 3. So very simple. Why? Because the Thomas is diagonal matrices. All right. So now I share with you some my friend here. All right. So my friend here, where is my friend? Okay, Amelia Aziza. Okay, Amelia Aziza, can you write what is different? What is the difference between, okay, Dolittle and Thomas? What is different between Dolittle and Thomas? If somebody out there, all right, in the class here, okay, can you please answer my question? All right, my question is what is the different? My question, what is the difference between crowd and Thomas? All right, and Thomas. Okay, this is my question. All right. What is different between crowd? Okay, this is my question. Can you answer? Dolittle. What is different between Thomas and Dolittle? What different between crowd and Dolittle? All right. So also, what is different? What is the difference between Kolesky? We already have Kolesky method, right? And Thomas. All right. So please answer my question. I'm waiting. Somebody answer my question. All right. What is different between Thomas and other method that you learn? All right. So now, come on. If I can get Amelia Aziza Fatana, if you can answer me a question. What is the difference between the Crowd and Thomas, Thomas and Dolittle, Thomas and Koleski? All right. Can you answer my question? Okay, I'm waiting.
And doctor, the difference between Dolittle and Thomas is, I think, the A, matrix A.
Uh-huh.
For
Dolittle
Thomas,
matrix.
diagonal,
Thomas is diagonal. Dolittle, full matrices.
full
Am I right?
matrix. Yes.
All right. So now, how about the difference between Crowd and Thomas? Okay, somebody can, Aziza or Fatana? Okay, Fatana or Aziza, can you answer my question? What's the difference between Crowd and Thomas?
Difference. The difference is hello,
Huh?
hello doctor.
Yeah, ada. Dengar. Here, very clear, very clear.
Hello doctor.
Everybody can hear you. Yes. I'm very clear. Your voice is very clear.
Okay, the difference
Hmm.
between Crowd and Thomas. Crowd is the full matrix,
Uh-huh.
while Thomas is only diagonal. Diagonal
Only
matrix.
Thomas diagonal. Very good. So what is different between Koleski and Thomas? Okay, somebody can answer me?
If
Mm-hmm.
Koleski symmetric
Symmetric.
matrix, while
Yes.
Thomas diagonal matrix.
Very good. So in Koleski, the upper is a L transpose. Okay, Koleski is a L transpose. All right. And then Thomas, okay, they can use Crowd. Okay, one of the solution. Thank you very much. Very good. Very good. All right. So now we already done. Okay, what we done just now? We done already the direct method, okay, solving a linear system of equation. What is that? Okay, please refer to the book. I hope you need to have a book. If you have, okay, get from your senior, all right. So from this book, we learn the direct method. The first is a Gauss elimination. Second is a Gauss elimination with partial property. And then we do four matrix for using the factorization for matrix A is a full matrices. We can solve using Dolittle and Crowd. Okay, it's depend on the where the value of one, okay, for diagonal, whether upper or lower. If lower, we call as a Dolittle. If upper, okay, we call as a Crowd. And then we can also use Thomas, okay, use with a crowd style, okay, because the matrix A is a diagonal. And then Koleski is special because there are so many conditions. The first is symmetry and positive define. So we can solve this problem. All right. So now you can go to the exercise. Okay. Go to the exercise. Okay. You can go. You need to do the exercise because all right, because we want you to make sure you can understand how to use a calculator and then how to solve this problem in 20 minutes. All right. So you can go to the exercise 2.2. You can solve Thomas and Koleski number 8 to number 17. Number 8 to number 17. All right. You can see here. All right. So I will distribute this question to the group. All right. To the group using, maybe I'm using Padlet. Okay, so we finished already. We want to go to the iterative method. All right, we want to go to iterative method. There are two ways to solve a linear system. The first is direct method without iterative, and then the other one is an iterative method. All right, okay. Okay, when we talk about iterative method, nobody want to answer my question? All right, nobody want to answer, please. Okay, from out there. Okay, since we have Fatana, Emilia, and Aziza, okay, please, if now everybody want to write your answer, all right, thank you very much, means that you confirm your learn, okay, my subject, all right. So now, I want to go to another topic, what we call as an iterative method, all right, what we call as a iterative method, all right. I share with you again my slide here. All right. Okay, I share with you the slide. Okay, my method is called as an iterative method. All right. So what is an iterative method? All right. So I go to I focus now. Wait for a while. I focus with you the iterative method. I hope I'm very clear this video. All right. Okay. Okay. You can make it your screen big using the YouTube. Okay. So what is a numerical method using iterative method? Okay. In this case, you learn already iterative method in chapter 1. You solve bisection method, four position method, Newton method, second method, fixed point method, all is an iterative manner. But the value that you want to find is only one. There is only one route to solve this iterative method for nonlinear system of equation. All right. So now we want to solve using how many? How many? How many? We want to solve using how many method? How many method for iterative? Okay, two method. All right. So we want to solve iterative manner. Okay. What is that? Okay. All right. Okay. We know that. Yeah. The iterative it should be k equal to 0, k equal to 1, k equal to 3, k equal to 4. ijk will be a grid for matrix. All right. ij is a grid, so we put k is a number of iteration. All right. So iteration here, not I for nonlinear is a grid, is an iteration, but I for chapter 2 is a grid. K is an iteration. All right. So we introduce you again. K is an iteration. Ij is a grid. All right. Ijk is a grid. K is iteration. All right. So now I introduce K as iteration. All right. So now, okay, there are two methods. Okay, that we learn under iterative method. This is not direct. Okay, you need to go for the iterative manner. Jacobi method and Gauss-Seidel method. All right, what is the iterative method? Under chapter 2, linear system of equation, is a Jacobi method and Gauss-Seidel method. This is the name of people. All right, Jacobi and Gauss-Seidel is a mathematician. They feel that to solve a big problem, all right, they can solve using Jacobi and Gauss-Seidel. That we call as a traditional method. Okay, traditional, classic method. Okay, so now my question, what is different between solving non-linear equation and non-linear system of equation using iterative? So now I want somebody answer this question. Please, okay, please answer. Okay, where is the rest? Okay, please answer my question. I want somebody right here, okay, I move on, all right? What is different between solving nonlinear and linear equation with iterative method? Meaning that we want to avoid Gauss elimination, Dolittle, Kraft, Kolesky, and Thomas. We want to focus on iterative method using Jacobi and Gauss-Seidel and the iterative method that you learn for nonlinear. All right, please answer my question. Can you answer my question? What is different between solving nonlinear and linear system of equation using iterative method? Now, please answer. I am waiting. Please write your answer. Yeah. Who want to answer?
Solving nonlinear will be we will get only one root, while linear equation we will get many roots.
Many roots. All right. So many roots, but this process is similar. Very good. Okay, very good. I think just now is Aziza ke Amelia tadi tu? Aziza, Amelia. Aziza. Okay, okay. Aziza. Okay. All right, Aziza. Thank you very much for your answer. Okay, very good. For the nonlinear, you just get one iteration. So you use xi, x2, x3, x4, x5. I is a iterative or the movement of grid. But the linear system, I is a grid, K we put as a iterative. All right, very good. All right, so let's we continue. Okay, very good. So now, as usual, I said that nonlinear we only use one root. All right, xi. But linear system of equation we also have one root, but the set of root x1, x2, x3, a set of root. Okay, that's we call as a linear system of equations. All right, so we have a set of a solution x0, x1, x2, x3, x4. All right, so if I'm using start from x1, I put x1. All right, so this is different. So now, okay, let's we go to solving a linear system AU equal to F. A is depend whether A is a full matrices or diagonal matrices or Kautsky style, positive defined or symmetry. Okay, symmetry. Okay, okay, wait, huh? All right. So now you are given the matrix A x equal to F. Okay, A11, A12, A13, A21, A22, A23, A31, A32, A33. Okay, S1, S2, S3, and then the right hand side is given in the question S1, S2, S3, F1, F2, F3. So you already know how to transform the matrix form to the linear system. All right, just now we transform the linear system to matrix, but now we transform matrix to the linear system. So we want to find what is x1, what is x2, what is x3 based on the diagonal expression. All right, you can see here, okay, x1 is equal to f minus a13x, A12, sorry, this one is a A12x2 minus A13x3 divided by A11. All right, so for the second row, you can get x2 equal to f2 minus A21. This one correct, I will correct already. A21 x1 minus A23 x3 divided by A22. Okay, and then the last row, okay, x3 is equal to f3 minus A31 x1 minus A32 x2 divided by A233. So what you do now is you get the value x1 based on the diagonal value. So you can get divided by A22, A33, A11. All right, so the same terminology, the way how you transform, all right, matrix to the linear system, you can solve using Jacobi or Gauss-Seidel. Okay, you can solve using Jacobi or Gauss-Seidel. All right, so now I go to your friend here. All right, I have a friend here, many friends here, Aziza, Amelia, and Fatana. All right, so I have a question here. IJ. All right, so what is different? IJ. Yes, we have IJ. Okay, because we have a matrix 2 by 2. But what do you mean by IJ? Can you explain? Okay, Jing. All right. So now, can you explain, Jing? I'm waiting. Okay, IJ. Yes, I is X direction. J is a Y direction. So your matrix A is a full, all right? But the matrix that you need to find is 3 times 1, x1, x2, and x3. You have a 3 set, all right, for solving a linear system. Okay, now, okay, what's different Jacobi and Gauss-Seidel? Aziza, Amelia, and Fatana, all right? And then the rest of you, okay, at the YouTube, all right. Jacobi, they're using the old value. Gauss-Seidel is the best one because they are updating the value. All right. If x1 is already done, so they use the x1 for the next iteration. Jacobi, no, they're still using the previous iteration. Okay, they're using old value. So when I have this type of definition, Jacobi and Gauss-Seidel, okay, we already know when we use update value, a new value, all right, the result is very good. So meaning that Jacobi is better than, Gauss-Seidel is better than Jacobi because of the updating value for X, all right? So Jacobi is a weak because they are using the old value, all right? Okay, this is the problem for Jacobi. That is explicit, all right? However, Gauss-Seidel is an implicit. Okay, it's an implicit, considered implicit because you always updating the value at the specific number of iteration. All right, so I will explain how you draw the solution. I will explain how you write the answer in the table form. All right, so the concept The mathematical thinking, same as solving a non-linear. However, linear system, you have three, x1, x2, x3, okay, system. Okay, I focus now, Aziza, okay, Amelia, and then Fatona. I focus to the, okay, Jacobi and Gauss-Seidel. I already told you the difference. So the basic is you transform x1, x2, x3 by dividing the diagonal value a11, a22, a33. All right. I forgot to mention here, a11, a22, a33 should be the biggest value compared to the rest, because when we divide a biggest value, it's same as Gauss elimination. The result, okay, with partial proverting is very good because the value is small because we divide the big number. All right, so now we get a difference between Gauss-Seidel and Jacobi. Gauss-Seidel using the previous step, the previous iteration. Sorry. Jacobi, they are using a previous iteration. Gauss-Seidel, okay, they are using the latest value at the specific number of iteration, at the current number of iteration. So all same, they start with the initial guess. We need to give you the initial value to start the iteration. If same as the nonlinear, you need to given the initial value as initial guess to start the iteration. Second, I want you to familiar with this notation. Okay, there is a X subscript, there is X, okay, superscript. I want you to remind yourself that for K subscript is an iteration, number of iteration. I, okay, is a grid. You have x1, x2, x3, x4. There is a knot, there is a point. All right. So now, okay, when I said that xk I means that xi for the iteration k. All right. So now, okay, I would like to express here, okay, if I want to write the Jacobi iteration. All right, so I can say that x11 equal to f1 minus a12 x2, all right, and then minus a13 x3 divided by a11. All right. However, x20, x30 should be the previous, the initial condition. You get from the initial condition, the previous step. All right, so x2, you already have x1 naught minus a13 x3. This one is not a13. a21 a23 x3 naught divided by a22. All right, so this make sure that you correct. Okay, I will correct this one, a21 and a23. So x1 naught, x3 naught still in the previous step. What is the previous step? Is the initial guess, in the initial value, the start, the iteration. All right, so meaning that Jacobi, they're using all version, all value, same as what? Same as Dolittle, all right, same as bisection, same as Newton, same as forward position method. Okay, they are using all the previous. However, okay, this one, okay, this one is a second iteration. They need to find x1. Okay, you can see here. Okay, after s2, Jacobi. All right. Okay. Okay, you can see here. All right. For second iteration, x2 also they are using x. Okay, x and 1, the iteration that you get from the previous step. So you can call from the previous iteration x21, x31. All right, that you get from the previous iteration. All right. So all the parameter is similar. However, the value for x21, x11, x31 all at the previous step, previous iteration. All right. So we can write, okay, we can write the equation for Jacobi is like this. Okay, when the matrix is full. All right. Same as kalau Dolittle is different. It's a direct method. Okay, but this one iterative manner. UIK plus 1, the new iteration, equal to 1 divided by A11, okay, A22, A33, times BI. BI is an F, Fi, minus summation Aij Xj, where I is not equal to J, J start from 1 up to N, where Xik is a whole value. So this is a Jacobi. They are depend on the old value. So meaning that the slow moving to converge. This is the weaknesses of the Jacobi. So same as a nonlinear system of equation that we learned before, okay? Okay, we need to stop the iteration. Okay, we need to stop the iteration. There is a condition to stop the iteration. All right, so now I share. Okay, I want to make friend here. All right, with Amelia, Aziza, and Fatona. All right, so the number of iteration, good. Okay, K is they use the iteration K. Yes, very good. Tai Jin Kong. All right, so you are really want to answer my question. Okay. Okay, my question, the next is, what is the computational molecule? So I give one terminology. What is a computational molecule? This is a computational molecule. All right, so you have to know that, okay, whatever way we write, we can easy to put I minus 1, all right, because this one is I0, I1, I is equal to 2, I plus 1 is equal to 3. This one is a 1, 2, 3. So I put I minus 1, I plus 1. All right, K, okay, this is an iteration, the new K and then the last K. So from this equation, you can see here, okay, if I want to, okay, focus my lecture here, all right. So from here, you can see the I, okay, xik plus 1 is here, is depend on the aij, okay, on the left, and aij I plus 1 on the right. So meaning that to get one iteration is depend on the 2 point at the corners, okay, 2 point or 3 point. Kalau diagonal is a 3 point, all right. So this is the way how we write the computational molecule for Jacobi. Okay, what is a computational molecule? Okay, the grid involved in one step, okay, iteration. All right, so the next is a Jacobi table. All right, so you have to know, you want to find x1, x2, x3. All right, and then you have an iteration, k equal to 0, k equal to 1, k equal to 2 until converge. So at the first round, the first grid is a initial condition. So now I stop. Okay, what is the initial condition? I want to ask your friend here. Okay, Fatana. Okay, what is the initial condition, Fatana? You learned already initial condition for solving a nonlinear equation using Newton method. Okay, second method, you have a 2 starting point. Newton method, you need to have 1 starting point. Fixed point, bisection method for provision, all you need 1 point. However, second method, you need x0 and x1 at the boundary. So what is the initial value? Okay, my question here is what is the initial value? Or
The
sometimes
initial value is 0 kan, Doctor?
if a starting point kan, to start the iteration kan, is a given in the question. Is a given in the question. So thank you very much, Fatona. Very clear.
Doctor.
All right. Yes, very good. Okay, thank you very much. Okay, I continue. Very good. All right. So this is you start the iteration. Okay, last time you're using only one root, x1, x2, s1, s1 for this different number of iteration. But now you have a three value you need to find. If you have a 3 iteration, you need to find how many? Okay, 9 to 12. Okay, calculation. All right. So same as nonlinear, you need to control your iteration by this condition. Xik plus 1 minus xik. I is a grid, yeah. I is a grid, 1, 2, 3. K is an iteration. So how many times you need to do the calculation? Many lah. All right. For first iteration, you have 3 types of calculation. For second iteration, you have another 3. The second iteration, another 3. So means that you have a number of iteration because you have many grid. Okay, S1, S2, S3. But control for every I. I means that 1, 2, 3. All right. So this is a method. The way you solve is based on the previous value. Same as Same as bisection, four position method, four position method, apa lagi, right, fixed point iterative method, all using the previous value. So now, my question, how to solve a Gauss-Seidel method? So I'm still using the same metric. Okay, metric is a 3 by 3, A11, A212, A13, A1, A21, A22, A23, same. I'm using the same matrix, all right? And then I convert, okay, I put down, okay, I'm using the same matrix. I get the way how I transform from the matrix to linear form. I copy paste, I drag, I put down, okay, I put down because I know that Jacobi and Gauss-Seidel, I can use this type of transformation from matrix to the linear, all right, same as, okay, I'm not changed anymore. But the way now, how I calculate the value x2 and x3, there is a problem because I'm using the update value, the very, very new value, the current value, all right? So, okay, the first iteration, okay, I start. I want to find x1, all right? Okay, I know that S1 is equal to F1 minus A12, A13, X2 minus A13, X3. All right. And then I know how to find another X2 and X3. Okay. So now how I want to put the value of K. This is my problem now. I put the value of K. Okay. X1K, okay, I make it more simplest. Okay, I know that the initial condition is Xi0 is equal 0, X1 0, X2 0, X3 0. All right, okay, I put the initial condition like that. All right, so I know what is Xi0. 0 is the iteration, the initial iteration, the starting iteration. Okay, so now I delete. I just focus my first iteration, yeah, my first iteration. Okay, my first iteration here. Okay, I finish or not the iteration? The first iteration, okay, this is the first iteration. What is different? You see, okay, for x1, I put k plus 1, x2 is 0, x2 is 0, x3 is 0, all right? But for x2 is an iteration 1, x1 0 because initial condition, x3 also 0. For x3, x3 1 first iteration, x1 0, x2 0, all right? So because this one is a first iteration, I need to use all at the initial condition. All right, so for the second iteration, okay, x1, 2, okay, I'm still using x2 and x3 at the previous step, at the previous iteration, all right? Okay, so now, this one is a Gauss-Seidel. This one is a Gauss-Seidel method, all right? So for Gauss-Seidel, okay, I want to change x1, 2, which is I got from the previous step, I can apply here. I can use this value here. All right. X3, 1 is still not calculated. I'm still using the whole iteration. For the X3, I'm using all, okay, I'm using all new iteration. You know X3, you can see X3 here. X3 to X2 already done from the previous step. X1 also already done at the previous step. X1 also is previous step. So for X3 to, I'm using all at the new time step. All new time step. All right. So the third iteration also same. All right. For okay, X1, F1, A13, X2, A1, this one is a A12, and this one is A13, X3. Okay, I'm using the previous iteration, but to get X13, which is already done from the previous step, I put, okay, X13, the third iteration. Okay, for the last grid, all the value X2 and X1, S2 and S3 is a update already at the previous step. So the computational cost, okay, the computational molecule is what? All at the similar iteration. For example, if you want to get I is equal to 2, you need to use x1 at the previous, okay, at the new iteration. The last is a previous. All right, so is different with the Jacobi. Jacobi depend on the 2 point at the previous step, at the old step, but Gauss-Seidel, they are using the new iteration. The last iteration, they are put in the straight line. Okay, the last is all at the k plus 1. So the function of Gauss-Seidel method is very good. You know why? Because Gauss-Seidel using what? Using the new iteration. So the way how I write the formula is in a two part. The first part is a new iteration. The second part is a previous iteration. So this is the best of the Gauss-Seidel. I write in the two part. The first part for I minus 1, okay, I use xjk plus 1. All right. For I k plus 1 up to n, I'm using the previous iteration. You know why? Because I still not get the value. All right, so you can see because you have a new iteration k plus 1 for xj, this is a superior of the Gauss-Seidel method. All right, the table of the Gauss-Seidel, I want to stop here. If I can get a feedback from the rest, okay, for example, Fatana, Amelia, Aziza. Aziza, what's different the table that I'm going to draw between Gauss-Seidel and Jacobi? Okay, how the table? Okay, how the table of Gauss-Seidel method? What's different between what is the
iteration.
different? The iteration lagi. The iteration of the Gauss-Seidel is much more lower. The number of iteration much more lower compared to Jacobi. Second, we want to find x1, x2, x3. All right, for the number of iteration k. Okay, same as the table similar to Jacobi. However, the number of k is a minimum compared to Jacobi because Gauss-Seidel using the update value from the previous grid, all right, from the previous grid. So this is the way how you draw the table. To get x2, you need to get x1 from the previous step, all right. To get x3, you need to get the previous steps. For example, x2, 2, okay, x1, 2, you need to use the previous step, okay. All right, so you, okay, meaning that Gauss-Seidel, they're using the previous value. Be careful, yeah. So same as Jacobi, you need to terminate the iteration because of the number of iteration, okay. The value of I for the new iteration minus the previous iteration is less than epsilon, all right. For every I is equal to 1, 2, 3. So we terminate the iteration because all the value of xi is less than epsilon. Epsilon is what? Is a convergent criterion. Same as nonlinear system of equation that we learned. Epsilon is a convergent criterion to control the number of iteration. Right? So that is a Gauss-Seidel method. Okay, that is a Gauss-Seidel method. Okay, since I never told you any about the method, so it's really burden you. However, you have the books with you. All right, you have a book with you. So I want you, okay, to solve this equation. If I can get this equation, all right. So I open the directory, Thomas Gauss-Seidel. All right, I open here. Okay, I want you to send me an answer. Okay, all right. So I cancel here. I share with you the PDF file. All right, my question here. I want you to answer this question. The first question, okay, please be careful, all right? So let's go to the question. I focus the question. I want you to have this question. Okay. I share screen again with you. Okay, I go to the question. I hope you can understand me. Okay. Okay, what is the question? The question is, okay, look the question. The question is, please differentiate between Jacobi and Gauss-Seidel method. Please use your calculator to calculate. Alright, what is different between Jacobi and Gauss-Seidel? If I give you the initial guess, the initial condition x not equal to 111, alright, you want to solve a linear system. I already write the linear system. X1 is a 2x2 minus x3 divided by 2. X2 is x1 plus x3 divided by 2. X3 is equal to x1 minus x2 divided by 3. Please remember, your initial condition is always 1. So what is a solution for Jacobi to solve this linear system, and what is a solution for Gauss-Seidel? I'm waiting for you, alright? So means that you need to write this table. Okay, what is the value for x1, x2 and x3 for Jacobi, and then what is the value for Gauss-Seidel for iteration 1 for x1, x2 and x3. Can you fill all this form? Okay, I already write the linear system. X1, x2, x3 is given, and then I also given the initial condition always 1. All right. So I want to you answer my question. What is the value for first iteration? Okay, first iteration means that the first iteration here. What is the value S1, S2, S3 for Jacobi and Gauss-Seidel? Because I want to see the different. Okay, I want to see the different. Can you go for this answer? Okay. Okay, I put very minimum. All right. So you have a linear system here, and then you need to answer what is the value for first iteration for Jacobi and Gauss-Seidel. Very easy. All right, because the initial condition is always 1. The linear system also very simple. All right, I'm waiting especially for my friend here. Okay, my student here. All right, who's there? Is Aziza, Amelia, Fatona, and also my friend here. Okay, in the YouTube. All right, in the live YouTube, please answer my question. How to fill the table by using Jacobi and Gauss-Seidel. Then I told you Jacobi using the previous value, and Gauss-Seidel they are using the latest value. All right, can you do it? I'm waiting. Okay, I'm waiting. Okay. All right, find x1, x2, x3 for Jacobi and Gauss-Seidel. What's different? Okay, I want to see what is different. Is it the value similar? Is it the value different? Come on. I'm waiting. Okay, I'm calling for G. I'm calling for Jin Pa. I'm calling for Eric. I'm calling for Purani. All right, who are joining me. Okay, the YouTube. All right, please joining me. I'm asking you what's the value, since you are familiar in chapter 1, how to iterate, how to generate the iteration, how to generate the value based on the iteration for xi. All right, but in our case, it's a xi, I is moving from 1 to 3, and k is a number of iteration. Okay, all right, k is the iteration. Please, I'm waiting your answer, please. Okay, Emilia, Fatona, what is the value for x1? Okay, please remember the computational molecule for Jacobi depends on the previous iteration. Okay, for Gauss-Seidel, the latest. You always updating x1, x2. All right, you're not updating s3 because s3 is a you not calculate s3. All right. So come on, I'm waiting. What is the Jacobi and Gauss-Seidel for first iteration? First iteration, I just want first iteration Okay, I just want first iteration for the Jacobi and Gauss-Seidel. First iteration only. Yeah. Can you find here first iteration only? Alright, I'm waiting. Any feedback? Any feedback? Mm-hmm. Ada feedback? No feedback? I'm waiting S1, S2, S3. Okay. How to
Doctor,
put? Yeah.
for Jacobi, to
Uh-huh.
find x1, x2, x3,
Uh-huh.
I just substitute the value from x0 that was
Ya
given
betul.
in the question.
Yes, yes, correct. You are correct. And then the answer? You get the
And
answer?
for x1 is 1 over 2,
Mm-hmm.
x2 1,
Mm-hmm.
x3 is negative 1 over 6.
Negative 1 over 6. So come on, we go to the solution. Okay, for Jacobi is a 2 times 1 minus 1 is 1 over 2. Right? Betul.
Uh-huh.
S2 is a all value 1 plus 1 over 2 is always 1. Alright, X3 is a also all value 1 minus 1 divided by 3 is equal to 0. Betul?
Saya
Tak?
silap-silap.
Sebab dia nilai lama je. You are using the old value. For Gauss-Seidel different. Alright, for Gauss-Seidel, okay, to get x1 and x3, you are using old value 1. 2 times 1 minus 1 divided by 2 is 1 over 2. But for x1, okay, you need to use the previous step. Okay, the latest one. X1 is 1 over 2 plus 1 divided by 2. So this one is different. 1 over 2 is a Jacobi. They're using the latest value. Alright. For X3, okay, because we are using X2 and X1, so all is a new value. X1 is 1 over 3, 1 over 2 minus X2 at the previous step. Previous step is equal to 3. Divided by 2 is a negative 15 over 2. So what is different Jacobi and Gauss-Seidel? Jacobi using the old iteration. Gauss-Seidel is using the latest value for the current iteration. Right? The latest value for the current iteration. So you can see how speed the Gauss-Seidel and Jacobi. So you are going to use these value, all right, and put it in the matrix, okay, and then continue the iteration until converge. All right, meaning that all the value of xi is less than epsilon. Okay, so thank you very much for give me a feedback. Okay, thank you very much. Okay, since you are trying to answer the rest. How about the rest? There is no feedback from Jin Kong. There is no feedback from others. Pa, where is Pa? Alright, where is apa lagi? Ramai tu. Okay, there is no feedback. Alright. Okay, can I have one feedback from you? Okay. I'm waiting. Okay, thank you very much. Okay, you are given already your email. I'll post you the question, okay, where you can get through the Telegram, all right, okay, or at the e-learning, you can post also at the e-learning. All right, so now, can I have a feedback from others? No? No feedback? No answer? All right. No answer. I'm waiting from you. Alright. Siapa tu? Azizah dah ada. Okay. Hi. Okay. Go. Okay. Haiza. Okay. Hazwani. Amelia. Why? Why no answer? Okay. Why you are not give me a feedback through the YouTube? Okay, if there is no feedback through the YouTube, we come back to Zoom because I call your name account. I can double check your attendance. All right, using some notation here. All right. So now, please do it
Doctor,
again. Yeah.
X2
Ya,
for
Fatana.
Gauss-Seidel tu bukan 3/4 ke?
34 ke? 1/2. Okay, you go to the question. Okay, we go to the question here. Okay, sorry. Okay, I go to the question here. Am I right? This is a question. Alright, kalau Gauss-Seidel, okay, S1 is already done. S1 is 1/2. Okay, plus S3 is already, we still not get S3. S3 is equal to 1. So 1/2 plus 1 divided by 2, because the question asks you to divide it by 2. So you will get 1/2 plus 1 is a 3/2 divided by 2. Berapa? 3/2. 3/4. Alamak, silap pula. 3/4 ya. Alright. 3/2 divided by 2 is times 1/2 lah kan. 3/4. Sorry. 3/4 lah jawapan dia ya. Kalau betul kan 3/4. And then now here also you need to change 3/4. Okay, because the question is x1 minus x2. X2 is a 3/4. Please correct my here. Okay, my here 3/4. Alright. So 1/2 is correct. So the answer is different. Okay, please correct this one. I will change at the notes. Alright. So the important is you change the value. The important is you change the value for the previous, okay, the previous value of SI, okay, in the current time step. Okay, in the current time step. Thank you very much, Fatana, you correcting me. Okay, the rest, okay, can you correct me? Okay, I'm waiting from the sama je answer doctor. Oh, sama salah. Siapa? Jin Kong? Because 3/4 ni tersalah saya kan 3/4. Alright. So thank you very much. Okay, we end the session. Get your attendance. Okay, and then I will send you the working in the group, especially for mind map and then the question for chapter 2. Alright. We still not finished chapter 2 because we want to go for the example Jacobi and Gauss-Seidel. This is a small example. Okay, this is just a small example to show to you. Okay, what you want to show, what we want to show to you is how you control the iteration for Jacobi and Gauss-Seidel. Okay, for Jacobi and Gauss-Seidel. All right. So thank you very much. Okay. The next, since there is no feedback for today class, okay, I have no feedback from today class, so I will use Zoom again, right? Zoom again after this. Okay, numerical method ada soalan proving ke? Adalah soalan proving. Oh, proving. Proof. Okay, proof. Okay, mungkin. Okay, not chapter 2. Chapter 2. No, not chapter 2. Maybe chapter 1. Okay, chapter 1. Apa dia? Kolesky. Okay, positive define, and then another one is symmetry. Okay, symmetry. Alright. So maybe positive define and symmetry for Kolesky matrix. Okay, for Kolesky. Okay, for Kolesky. Alright, yes, this is a very good question. Alright, so now, thank you very much. Okay, please fit in your answer here. Get the solution, alright, and then get a difference between Jacobi and Gauss-Seidel. Thank you very much. Okay, bye-bye. Alright, thank you very much for Fatana, Amelia, Shiha, and then Aziza for company me. Alright, so the next coming, I will, thank you very much, Jin Kong. Okay, Jin Kong already done the answer. Thank you very much, Jin Kong. Alright, so next coming, I will invite Jin Kong, can or not? Okay, to join me the class. Okay, Okay, maybe if you are using in the Zoom, so all are invited in the class. All right. Thank you very much. Any question before I end the class? Any question? Okay, from the previous class? Any question? I'm waiting. Okay, any question? Come on, you need to register in YouTube when you want to ask a question. All right, Elia, thank you very much. I want you to have any question. Aisha, thank you very much. Okay. All right, so all here. Okay, how about the question? Okay. Any question? No question. No question. Okay, all right, no question. All right, so please go to the exercise. Okay, whatever you do, you need to go to exercise because calculator is very important because calculator will show your skill, right? Will show your skill. Okay, bye-bye.
Thank you, Doctor.
Thank you. Thank you, Emilia,
Thank you,
Fatana.
Doctor.
Thank you.